Can computers think? And could we ever have a computer that is able to think? My name is Tabitha Njibet, and today I'll be taking you through these two questions. A debate on whether computers can think began with Alan Turing's paper, Computing Machinery and Intelligence, published in 1950. In this paper, he posed the question, can computers think? This presentation explores some well-known arguments in order to provide an answer and also address whether computers could possibly be capable of thinking. Alan Turing proposed the test to gauge computer intelligence. Today it's commonly known as Turing's test. In this test, an interrogator was separated from a machine and a person, with the only form of communication between the interrogator and the two being text-based. The interrogator's task was to pose questions to the two respondents in order to determine which of them was the machine. If the interrogator failed to do so, then the machine was believed or was said to possess intelligent behavior. There have been criticisms over the years concerning this test. One of my concerns is what would happen if the machine that once passed this test failed when under a different interrogator? Could this machine still be said to possess intelligent behavior? Besides this test also examines only one aspect of human intelligence, the linguistic aspect. So what happens if an individual limited in skill in this area happens to be the interrogator? What can be said of the results? I also believe it is too narrow a view to define thinking as simply a process that takes inputs and processes them into outputs using a given set of instructions. I believe human intelligence is also not enough for us to declare the machine as having or displaying intelligent behavior. John Searle goes on to provide his argument. He argued that syntax does not equal semantics. In his thought experiment, the Chinese room argument, he claimed that simply having input and a set of processes that manipulated those inputs into outputs doesn't mean that thought is being involved in any way. Without semantics, there is no intentionality, John Searle claimed. Intentionality being the apartness of thought. Intentionality requires for there to be a conscious experience. So it can be concluded then that semantics doesn't equal thought, according to what John Searle provided. His argument was mainly against the advocates of strong AI, who claimed that or who maintained that computers could think and form opinions of their own. John Searle's critique also applies to Neuridian's fields, a connectionist kind of AI used to model or used in virtual reality and 3D models. Nerves are trained to recognize patterns in images, and from this they learn a continuous function that they use to map 5D coordinates to color and volume density. From this, they produce realistic 3D models of objects. It can be argued that nerves are just like the individual in the room in Searle's thought experiment. This is because they take inputs and process them into outputs through a set of iterations in which weights are being adjusted in order to fit a certain score. No thought is involved, only manipulation of the input values to produce output. There are also limits to what aspects of human intelligence can be modeled. The existing sets of symbols and formal systems are not sufficient enough to model certain axioms known to man, such as consciousness. There are challenges that lie in representing these axioms as rules that a computer can understand. So this makes it difficult, or this increases the difficulty in us having these aspects of human intelligence modeled in AI. And I do believe this is one of the constraints in developing an AI that can fully have human, or can fully be said to think and possess human intelligence to its full extent. It is from the perspectives I have presented and the arguments presented in this that I come to the conclusion that currently, and with the current technology that we have, we are unable to say that computers can think. So I believe that as of now, computers cannot be said to think. However, could we ever have a computer that is able to think? Nick Bostrom's simulation theory suggests that we may be living in a simulation. And if this is so, then aspects of human cognition such as consciousness, emotion, and intuition are all simulated. This means that our creators found a way or possessed the technology in order to computationally generate these aspects. There is a possibility then that we can do the same for the machines that we manufacture. This is only possible if this is within the constraints set for the simulation. However, this theory is unfalsifiable and impossible to prove. The limitations of formalization do pose a great challenge, like we discussed earlier. But perhaps there is some undiscovered, more rigorous system that is sufficient enough to handle the exceptions that exist currently. The odds of this happening are low, but they are not zero. However, I will highlight one issue. These systems are based on symbols. On symbols, in other words, they are symbolic. And as we explained earlier, syntax does not equate to semantics. So I believe there is no aspect of semantics in this case. It is also possible that these mental phenomena that we have discussed, like consciousness, may not be included in the subset of provable axioms in a newly discovered system that can handle more exceptions than the current ones that we have. So we're going to talk about the frame problem next, and the frame problem is one that is considered by a number of scholars to be solved. This problem poses the question of how AI will be able to judge relevancy. In this problem, a robot is tested to see whether it is able to make relevant, timely decisions in a given situation. Though this problem was mainly targeting symbolic AI, it doesn't mean that other categories of AI, such as NAFs, are immune to these relevance issues. NAFs, for instance, if trained on images that consistently had a light streak appearing due to a faulty camera, would produce output that still had the same light streak. This is because they're not able to judge between what is relevant and what is not. They also possess no understanding of the input that they process. Relevance is also subjective and dynamic. In other words, it changes or it varies from individual to individual. And even amongst these individuals, it is not static, but something that is shifting. Relevance, or what is relevant to an individual, is also shaped by what their experiences and background is. So this begs the question, how are we able to determine what is relevant in a complex situation that requires us to choose what is right and what is wrong? Human beings are fond of making decisions solely based on phenomena or mental phenomena such as intuition, one that they themselves do not understand. I do believe there's a lot that is left to discover and explore in in terms of human cognition and processes such as consciousness. It is the arguments and perspectives I have presented again that I come to a conclusion. The definition of thinking is subjective. Therefore, conclusions will vary depending on the individual. For the perspectives and arguments I presented, I choose to define, I choose to view intentionality and understanding as requirements for thought to be said to be involved. I do agree that currently computers are not capable of genuine thought, and it is quite plausible that they never will be. Much still remains to be explored in our current understanding of the human mind and development of more advanced technology. I do believe, though, that the limits of today may not be the limits of tomorrow. History has shown that a number of feats that once appeared to be impossible became possibilities. An example I would give is the innovation of the airplane. Perhaps there is or there lies a future in which all the hindrances to the development of a computer that can genuinely be said to think are non-existent. Non-existent. Thank you.